Simplified radical expressions. A couple of things I want to go over for the purpose of this lesson are what are radicals and what are factors, because these two things are very, very important. Radicals, you've seen them before. You might have remembered seeing something like this. These are radicals, radical numbers. Now, the number inside, these are called radicands. And of course, we cannot forget this symbol is not called the square root. This is actually called the radical. When the index of the radical is not visible, like this here, we don't see a number here, then it's understood that it's a 2, therefore square root. But this would not be a square root. This would be a cube root. This would be a fourth root, and so on. So these are radicals. Factors. What are factors? Factors are a combination of two numbers or several numbers that multiply to give you a specific value. For example, let's say I wanted to find the factors of 20. 1 and 20, 2 and 10. So basically, numbers that multiply to give us a 20, pair of numbers. Then of course we got 5 and 4, 10 and 2, but these are repetitive factors, so we don't really need to repeat them. This is what we would call the factors of 20. Alright, moving on. Method 1. Break the radicand into perfect squares and simplify. Perfect squares. What are perfect squares? Perfect squares are the product of a number multiplied by itself, like 2 times 2, 3 times 3, 4 times 4. This product, 5 times 5, is what we call the perfect square. Of course, the list keeps going. You might have seen them as 6 squared, as 6 times 6, 7 squared, 7 times 7, 8 squared, 8 times 8. Okay, perfect squares, these numbers. So I'm going to use this to simplify our radicals, starting with square root of 80. Simplify the following radical expression by using perfect squares. So I'm going to list the perfect squares here once again. And what we're going to do is we're going to branch off this square root of 80 and start off with two possible factors that give us 80. But we're not going to pick just any number. We're going to pick the list that we have here. So we're going to start with 4. Can 4 be divisible by 80? And the answer is yes. 4 and 20. Now we can keep going. Okay, so we got to break up the 4. We break these numbers up until we get to prime numbers. So what are prime numbers? Numbers that cannot be, that are multiplied by 1 and themselves. So they cannot be broken up by any other factor, just 1 and itself. So we could have picked 4 and 20, or you could have chosen a bigger number. Square root of 9. Is 9 divisible by 80? No, it's not, so it's out. 16. Would 16 be divisible by 80? The answer is yes. 25 wouldn't, 36 wouldn't, and all these numbers would already be way too large. So we could also have done square root of 80 and use the factor of 16. And then we would have had 16 times 5. We can break up the 16 with 4 and 4. 5 is already prime, nothing we can do there. 2 and 2, 2 and 2. But in the end, as you can see, we would have had the same result as we did here. So regardless of the number you choose, you should still end up with this prime factorization. Now the whole purpose of writing the factors is to put them in pairs. Now why in pairs? Because this is the square root. There's an invisible 2. So that means we have to put them in pairs of 2's. Okay. So you're probably thinking, oh, miss, you forgot the 4's. Well, no, the 4's do not count because the 4's, we broke them up into 2 and 2. So those numbers we cannot work with because they had already been used. So as we can see, 5 did not get paired. So that means in our simplified answer, we end up with the radical and the 5 goes inside. So the 5 becomes a radicand. The 2's, however, we're going to write the 2's once only for that group and once only for this group. And therefore, our simplified answer, finally, is 2 times 2 is 4, and the square root of 5. So, quickly, how can you check your answer? Well, what we do here is, since this number is outside of the radical, we need to double it. So 4 squared is 16. 16 multiplied times 5, because 5 is the number inside of the radical, and we get 80. Square root of 80 is what we had originally before we simplified. So that's one way to check your work. Next one, 125. Again, we're trying to use perfect squares. So we could use this to our advantage. It ends in a 5, so 25 has to be one of the factors. And sure enough, 25 times 5 gives us 125. So I'm going to keep breaking this into prime factor until I get to my prime factors. 5 and 5. Here's another 5. So what we're going to do now is we're going to put them in pairs, because again, we're working with the square root. So those 5's were paired. However, this 5 was not paired. So if you end up with something that is not paired, that means you end up with a radical. This 5 goes inside of the square root, and this pair, well, we're only going to write the quantity once. So 5 square root of 5 is the simplified answer of what we had here. Again, quickly, how do you check your work? Well, this number that is outside, you double it, and then you multiply it times the number that is inside the square root, and we should end up with the same radicand, and we do. Next one, square root of 81. Square root of 81, you go down your factors list, and you'll find that 9 is a perfect factor multiplied by 9 also. So 9 can be broken up into 3 and 3, and this as well. Put them in pairs. Now, we did not get a number that had no pair. This was not the case. So then we should not end up with a square root. There's no need for that. Instead, what we end up with is this 3, write the quantity only once. This group, write the quantity only once. So as you can see, nothing goes in there, so we don't need it. So 3 times 3 is 9. And 9 is the simplified version of answer of square root of 81. Method 2, use prime numbers or any factor and later group in pairs to simplify. So we can pick any number that we want to start off with, starting with square root of 72. Now, 2 is an even number. 2, 4, 6, 8. All of these are easy to work with because if you want to start off small, start off with 2. 2 definitely goes into 72 36 times. So then pick 2 factors for 36. Again, maybe you want to choose the 2. 2 and 18. Again, we can factor the 18, break it down. 2 and 9. And then finally, we can break up the 9, 3 and 3. Okay. You could have chosen any other different factors. It doesn't matter. In the end, we end up with these pairs here. So we are working with the square root, so we got to put them in groups of 2, in pairs, like a pair of shoes. So our final answer, we did end up with a number that did not get paired. That number goes inside the radical. This group, I'm going to write the quantity only once. This group, I'm going to write the quantity only once. But our final simplified answer has to be these two numbers multiplied together, 6, square root of 2. Next one, square root of 54. Once again, you can start off with 2 because 4 is even, so definitely 2 works. Or maybe you want to challenge yourself and say, okay, I'm pretty sure I can think of other numbers. 6 and 9. Okay. 6 can be broken into 3 and 2. 9 can be broken into 3 and 3. And that's it. We have reached our prime numbers. What we're going to do next, we're working with the square root, so put them in pairs. So, 3. We ended up with two numbers that did not get grouped, so those two numbers go inside the radical, but we got to multiply them. This group, I'm going to write the quantity of it outside only once. So our simplified answer is 3 square root of 6. And how can we check our work? Again, this outside number, if you double it, we get 9. And if we multiply it times the number that was inside the radical, we get 54. And 54 is our radicand. Next we have square root of a negative 30. So, compared to the previous problems, this has a negative value. This here is what we call an imaginary root. In Algebra 1, we don't mess with it. This is what we call it, imaginary root. And that's it. We cannot simplify it yet. Later when you get to Algebra 2, you will be able to. But for now, imaginary root is all we need. Next we have the cube root of 250. So, 250 is a pretty large number. And if I start with 2, I'm never going to finish. I'm going to be 2 and 2, and it's going to be a really long process. Instead, I'm going to think bigger. So, I'm going to see. It ends in a 0. So, for sure, 10 is a factor. So, 250 divided by 10 is 25. So, 10 and 25, perfect. Because I can easily break this up into 5 and 2, and this into 5 and 5. Now, we're not doing pairs anymore. This 3 tells you that you need to put them in groups of 3. So 5, 5, and this 5. There's my group. What did not get grouped, which is the 2, that is going to stay inside not the square root, but the cube root, so I need a little 3 there. This group of 5, I'm going to write the quantity outside only once, and that is my simplified answer. How can you check if this is correct? Well, this 5, we need to repeat it 3 times because it's the cube root. And that value, we multiply it by 2, and we should end up with the radicand that we had to begin with, which we do. Next one. Now we have simplifying radicals with variables. Not a hard task. It's pretty easy. So, what I'm going to do is I'm going to expand x to the 7th. So, x times x. Since we're dealing with the square root, we're going back to the square root. That means you have to put them in groups of 2. So, there's a group, and there's a group. So, my final answer is going to have an x inside the radical because I do have one x that did not get grouped. I had 3 x's, so there, there, and there. But instead of writing this as x times x times x, x cubed square root of x. And this is my simplified answer. Next one. The 4th root of y to the 11th. So I'm going to do the same thing. I'm going to expand. And since we're dealing with the 4th root, then we're going to put them in groups of 4. So that's one group, 2 groups, and these guys needed one more y to group. So our final answer is going to be the 4th root of y. There were 3 of them that did not get grouped, so y cubed. Here we had a group of y, so write it once. Another group of y, so write it once. These two give us y squared, the 4th root of y cubed. And this would be our simplified answer. And finally, simplify the following radical expression. The difference between this one and the rest is this has a coefficient in front of the radical. So, nothing different. We still break up the 54. This time I'm going to use 2 and 27. 27 we can use 3 and 9. 9 we can use 3 and 3. Okay. So we're going to put them again in pairs because this is a square root. So here's a pair of 3's and that's about it. What did not get paired, which is the 2 and the 3, go inside. This, I'm going to write it outside, but there was a 2 outside as well to begin with. So all we do is multiply those two. So our final answer would be 6 square root of 6. Next one. Here we have a combination of everything. So let's start off with the 48. I'm going to start with the number bigger than 2. Let's try 4. 4 and 12. So 4 can be broken down by 2 and 2. 12 can be broken down by 4 and 3. And then 4 can be broken down by 2 and 2. We're dealing with the square root. So we put them in pairs of 2's, pairs of 2's. What did not get paired, which in this case it was a 3, that goes inside the radical. So for now, I'm going to write this quantity once, this quantity once. Do not forget the 11 that is outside to begin with. And then of course we have our variables. So I'm going to expand and group in pairs. So as you can see, we have an x that did not get paired, so that goes inside the radical. We had 2 pairs of x's that got paired, so x squared. So somewhere out here, x squared. So I'm going to rewrite all this mess so it looks a little cleaner. 11 times 2 is 22. 22 times 2 is 44. So I'm going to start off with 44. And then we had our x squared, square root of 3x. This is a simplified answer of what we had here. And that is it.